Let's say you spend hours on experimenting and designing a PCB and it looks damn perfect. Now, how do you plan to get it manufactured? Okay, how do you find a good fabrication plant? How do you know if they deliver it on time? What about the quality? Is it the best price you can get? And the question keeps growing. To clarify all these questions, we have planned a series of videos where we would place PCB orders with various fabrication plants to find out answers for all these questions, so you can find the right manufacturer for your PCB. In this video, we'll start with PCBway. There is a high probability you know this manufacturer by now, as they sponsor half of the DIY channel here on YouTube. But we'll try to keep these videos unbiased and see what is the actual quality of PCBs they deliver. I received the package 10 days from the date I placed the order. For 30 PCBs, the cost was about $18.44, which is really good. But the cost of shipment was $23.68. Okay, that's somewhat justifiable based on the time of delivery, customer service, or let's say how safely it's delivered to me. But when the package arrived, I paid close to $35 on taxes and customs alone, which is absurd. It's almost the same cost as the entire order. But if you own a company, there are many ways you can reduce the cost of taxes and customs. But as an individual, you either have to compromise on shipping or end up paying a higher price for a good shipping experience. Other than these tax and custom problems, I did not face any major issue with the order placement or the shipping method. Now to clarify, this custom process may vary depending on where you stay. In some countries, there is no import tax on PCBs and electronics. And in some countries, like the one I stay, the import tax on PCBs and electronics are way too high. So this is not something PCBway can control or fix. It's a trade-off that we have to do while doing an international transaction or a shipment. So make sure to do proper research on your country's tax system and custom duties before you place any international order. To check and verify the quality of PCB, I have a basic checklist that walks through the topmost layer of the PCB stack up to the innermost. Since the PCB manufacturing industry is very competitive, most reputable brands try to get these qualities right. So if you are dealing with an unknown or a new manufacturer, you can use this test as a baseline to perform quality checks of the PCB. I'll put a link in the description where you can get this list. Also in the future videos, we are planning on making an elaborate version of this test using advanced tools and techniques to make the end result much more reliable and trustworthy. So make sure to be subscribed to the channel and let us know what you think about this in the comment section. Even though the silk layer is just for aesthetics and doesn't affect the electrical performance, there are a lot of products where the PCB aesthetic plays an important role. So having a good silk layer will reflect the brand image and the quality of the product. The PCBs I received uses a process called LPI, Liquid Photo Imageable, for printing silk layers. It's not the best option available, but it's pretty good. It's one of the most common methods used for silk screen printing. Now, to check the quality of the silk layer, let's put the PCB under a microscope to check for any printing defects like smudging, fading, or inconsistency in line thickness. In case if you don't own a microscope, a good magnifier should do the trick. Well, I don't see any issues here. Logos are sharp, text doesn't have any discontinuity, and I don't see any inconsistency in printing quality. Overall, the silk layer passes all the tests. Next, we have the solder paste layer. This is the exposed copper layer where the components are usually placed and soldered. In this layer, the quality depends highly on the type of surface finish. On this particular PCB, it went through the most common surface finish called hot air solder leveling, or HASL finish for short. To check the quality of this exposed layer, we have to check how the pads and the exposed areas are protected from oxidation, clumping of excess solder, or dryness from improper finish. Apparently everything seems good here and it passes all the tests. Solder mask is one of the most important layer as it insulates the PCB, also it protects the PCB from environmental corrosion. And the quality of this solder mask can vary based on the manufacturing process used. In this case, PCBway uses liquid epoxy solder mask for their standard PCBs. To test the quality of the solder mask, first we'll do a visual inspection by ensuring it covers all the required areas such as pads, traces and vias. Additionally, we can also examine the edges of the solder mask for any signs of lifting, peeling, or uneven thickness. And by having a closer inspection, we can identify smaller defects such as pinholes or cracks. The next test is not very scientific, but this should let us know how good the solder mask is at repelling the solder. So I'll apply some flux to the solder mask and then apply solder directly to the mask to see if the solder sticks to this layer. If it did stick, we'd know that the solder mask is either contaminated or it is of poor quality. But so far everything appears to be good. Next we have traces, which connects the components on PCB. And these traces are produced by a process called etching. Again, etching process can be done in multiple ways, but the PCBs which I received follows the wet etching process. So to know the quality of the traces, we need to check for signs of discontinuity, scratches or corrosion. Along with this, I'll also check if the traces are intact, free from any breaks or fractures, and check if they have uniform thickness and width. Unlike silk layer or solder mask, any irregularities or damages in traces will result in signal degradation or circuit failure. So to make sure we don't have any damaged traces, I'll also do a continuity test using multimeter to determine if there are any open or short circuits in the traces. And this PCB passes all these tests. Substrate is the fiberglass material that holds the traces, components and other layer of the PCB together. We would love to perform stress tests and check the composition of the material, but it would require more advanced tools and equipments. So for now, we'll just stick to visual inspection. So here on the substrate, we need to look for signs of delamination, cracks, warping or uneven surfaces. Also, we need to make sure the substrate is free from any visible damage that may affect its structural integrity or electrical properties. Now, after all this visual inspection test, let's see how the PCB performs during the PCB assembly process. So I'll solder some components on top of this PCB to complete the process. During the assembly, I did not notice any heat stress mark on the PCB, the traces weren't damaged, none of the pads were lifting off, and overall, all the pads had a very good soldering joint to the components. In this video, we tried to analyze and test some aspects of PCB quality. Even though most of them were visual inspection, it should give you a pretty good idea about the quality of PCB produced by different manufacturers. In this case, the PCBs from PCBway performed really well in all the tests. There weren't many mistakes I could find on the quality. But there is one little annoyance that I did not like about the PCB. That's the order ID printed on the PCB, which really messes up the aesthetic of the design. Even though you can get rid of it by paying additionally, I thought I would just mention it. Now, to avoid any misunderstanding, I did not perform all this test in a single order and call it a day. I did use both my personal and my client's previous orders throughout the test to get more consistent results. If you'd like to know why this particular tests were performed on each layer, I'll drop a link in the description which will help you understand how each layer is manufactured and how they affect the quality of printed circuit boards. And to follow up with more PCB content, make sure you're subscribed to this channel. And if you have any questions regarding this video, please go through this article that we have written on PCBway. And also feel free to drop a question in the PCBcupid Q&A section. Until then, keep learning and keep creating.